Okay, so this is number 3 from your exact value extra practice, okay? Sometimes it's a little tricky with questions like, particularly with question 3A, is that 3A can't necessarily be represented using a triangle that we have at our disposal here, and it's disguised. Its representation is disguised. So what I can do here is I can just reverse engineer the rationalization of the denominator, and that should help us see what's actually happening. So if I multiply by root 2 over root 2 again, I'll see that the cos of theta is 2 by 2 root 2, which I know to be, the 2's can divide out, we're going to be 1 over root 2. That's hopefully something that you've seen before in terms of a cosine. Now, I altered this question slightly because I wasn't happy with the 0 to 90 thing. That's not what I'm going to ask you. I'm going to ask you from 0 to 360 with these questions. So you have to ask yourself, you always draw your picture. After you get to this stage, you have some sort of like trig function and a ratio on the right side. You ask yourself, which trig ratio am I dealing with, and where is it positive, right? Because in this case, this is positive 1 over root 2. And so what I'm going to do is, this is where this kind of cast rule came from, right? So down in the cosine quadrant would be where cosine is positive, as well as the all quadrant, right? And so we have 0, 90, 180, and 270, and subsequently 360 here. And what I'm going to do is look for, or I suppose in the moment, I know that the cosine of theta, or cosine, is adjacent over hypotenuse, right? So my ratio tells me that I have adjacent over hypotenuse. Though I know this is root 2 on the hypotenuse. And anytime I see a root 2, that should clue you in that you're dealing with the 45-degree triangle, right? Because if I look at the other two, nowhere on the other two triangles do I have a root 2. Okay, so that gives me that I know that I'm dealing with a 45-degree triangle, which must mean that theta in this particular question has to be, if this is 0 and this is 90, that theta must be 45 degrees, and theta can also be, if I go all the way around here, that reflex angle. You can figure it out that way. You can go 270 plus 45, or you could just recognize that you're coming back to 360 and subtract 45, so you should be 315. Okay, those are the possibilities where, so for instance, the cosine of 45 is 1 over root 2, and the cosine of 315 is also 1 over root 2. Okay, so you need a picture for most of everything with this. Just always having those special triangles up top is a nice reference point, but that doesn't help us in finding, or it does kind of help us, but in ultimately answering the question, I need the angles. And so I got to draw those triangles in their respective quadrants, I suppose. There is a little bit of connection there, I suppose. Okay, question B. Question B is asking us for the tan of theta is going to equal root 3. So you have to ask yourself, where is tangent, or what is tangent? Tangent is opposite over adjacent. And where is it that I can get root 3 by 1? Or another question to ask too, I suppose, maybe before you're specifically looking for that, where's tangent positive? That's maybe a better second question. So draw yourself a picture, and the picture is going to have your cast rule on it, and you're going to ask yourself, where is tangent positive? So you write out cast. Tangent turns out to be positive here in the all quadrant, and tangent turns out to be positive down here in the tangent quadrant, right? Now, you ask yourself, I'll try to draw those similar size. You have to ask yourself now, how do I get a ratio of root 3 by 1? Well, if I know that this is my angle of reference there, then tangent is opposite root 3, and adjacent is going to be 1. Okay, and these two are negative because I went in a negative x direction, positive y, positive x, and negative y. Okay, so that's how I figure out these side lengths. That's important. But when we're dealing with questions like this, if you just know that tangent's positive and you figure out which quadrants it has to be in, it can't be in the cosine and it can't be in the sine quadrant, then you don't have to worry about the sines too much. That's why the cast rule exists. Okay, now we're going to figure out the tangent of theta. What does theta have to be in order to produce that trig ratio? Well, root 3 by 1 looks like 60 if I'm referencing my triangles. But the other thing you got to remember too is in a triangle, the reason why the hypotenuse is always the largest side length is because it goes opposite the largest angle. In an acute triangle with a 90 degree, the hypotenuse is opposite the 90 degree because the 90 degree is the biggest angle. And if we use that logic to go backwards, the next biggest angle would have to go opposite the next biggest side length. And in this case, 60 has to go opposite root 3 because root 3 is bigger than 1 but less than 2. So 1 is going to be your smallest side length. It's going to go opposite your smallest angle, right? And so it turns out on 0 to 360, using the diagram there, I can go, one of them is really easy, it's 60 degrees, and the second one is going to be your 180 plus the 60 degree triangle you built. So the second angle is going to be that 240 degrees. Okay, let's take a look at question C, and then we'll hit stop, and we'll continue with D, E, and F in a second video. Okay, so here, 2 sine theta has to equal 1. You got a little bit of solving here. You're just going to basically get sine by itself, so you can see what the trig ratio is that you're dealing with. So divide by 2, that drops out. You're left with sine theta has to be 1/2. Okay, so then you ask yourself the same question as always. Where is sine positive? So this question, because we altered it from 0 to 90, all the questions are going to be positive. But in some of the questions that I put on the test, we could have negative trig ratios. And then you'd have to figure out where would these respective trig ratios be negative. Okay, we basically have the opposite answers here to all these questions, right? In terms of which quadrants they fall in. So here, C, A, S, and T. Where is sine positive? Well, sine is positive in the all quadrant, right? And sine is positive in the sine quadrant over here. And now you're going to ask yourself, how do I build 1/2, given that sine is opposite over hypotenuse? So that means this is a 2 and that's a 2 because that's a hypotenuse. But our question is, what has to go in the angle of reference down at the bottom relative to the what we would have called the initial arm or the x-axis, right? And then we had our terminal arm come out. So I need to figure out where or what angle is that down at the bottom. Well, if this has to be 1 and this has to be 1, right, because opposite over hypotenuse, then that must make this angle down in here 30 degrees. And so subsequently, theta has to be 30 degrees, and theta has to be the 180 minus 30. Okay, so there you go. Okay, that's questions 3A, B, and C.